Thank you all for being here. I'm Shaundai Person. I am a senior software engineer at Netflix, formerly Sales Loft. Hi, Lofters. And today we're going to be decoding some common tech terms. So this is a tweet from Theo Brown from Ping. I don't actually know what Jamstack is, and at this point, I'm too afraid to ask. Now, there have been so many times where I'll be like in a conference talk or in a meeting, and I'll hear a term used, and I'll just do this. You know, the nod and the smile, because deep down inside, I have no idea what that term meant. And I'll hear the term used over and over time, I'll say to myself, why didn't I just ask what that meant in the first place? But now it's too late because I've been hearing it in stand-up every day, and if I go back and ask, people will know that I was pretending the whole time, and I'll look like a fraud, right? But the truth is that everyone has moments like these. Everyone has terms that they use or they've heard over and over, and they don't necessarily know what those terms mean. And they may have gone to look up the definition, but it might not have been clear enough. And there are also things that we do in practice every day that we don't always know that there's a technical term for. So for the next 40 to 45 minutes, this room is our safe space. This is where together we're going to decode some common technical terms as if we're a room of kindergartners, okay? No judgment. So everybody, you can take a deep breath. Okay. And actually the idea for this talk came out of an idea for a blog post. And I went around and I asked people which terms, if you could have them explained in ELI5 format, explained to me like I'm 5 years old format, what terms would you want? And I realized that a lot of the answers that I got back all kind of had to do with the realm of performance and optimization of performance. So for today's talk, we're going to go with the theme of performance, and all of the terms that we'll talk about will have to do with that bucket. So the first term, appropriately, that we'll define is performance. So when we talk about a performant app, what we mean is an app that our users can see and interact with as quickly as possible. And measures of performance are really centered around the user because after all, that's the reason that we're building the apps in the first place. So performance could mean how quickly your app loads, how smooth the transition is when a user clicks the dropdown, just the overall feel of the app to your users. And when we talk about optimizing performance, what we mean is that we want to enhance that overall feeling. And that's a simplified way of putting it. So when we talk about an app that's the front end of an app built in JavaScript or JavaScript framework, typically enhancements or optimizations to performance will fall in one of 4 buckets. There's data handling, and that's how we process, we represent our data. There's rendering, and this is how we display our data to the users on the page. The loading of the code, and we'll talk about JavaScript because I'm a JavaScript developer, but any code. So this is where the browser is loading and parsing your code, and then interactivity, and that's the relationship between your users and your application. So when it comes to data handling, there are a number of optimizations that available to you because handling data can be tricky, and mismanagement of data can really slow down your application. So in our app, which is server rendered, by the way, a request for data is initiated when the browser receives a request for a page, so when the user clicks on your page. And so what happens, where's the camera guy? Because I'm going to start running. All right, so what happens, this is, I'm going to model this. All right, I'm going to start on this side. So on the client, the user requests the page, and on the client, we make that request, and then we go over to the server to get the response back. The server sends over this data, and it sends it over the network back to the client. And now, if your user has a slow internet connection, or your app has a heavy amount of data, like most apps these days do, it can take some time before that response is sent. And the rest of your app is blocked from the next stage of rendering until that request is fulfilled. And what makes it worse is that if we don't have any additional optimizations, every time the user requests this page, every time the browser receives a request, we're going to have to go through the same process over and over and over. So caching is an optimization that we can add here. And so we'll define cache. This one is new to me. I use it all the time. And I'm such a phony because I didn't know what it meant until I wrote this talk. So what cache is a temporary store for your data. Okay, so with caching, on the first request, it's going to be the same deal. We're going to, on the client, I'm not going to do this again. On the client, we will make that request, go over to the server, and the server will send back that response of, the heavy amount of data. And then it'll go back to the client, but then it's also going to go to the cache. And so the next time that we have the request for the page, rather than doing that full round trip from the server and back, all we do is we just pop on over to the cache, grab the data, and then pop back over to the client, and we're good to go. So it's a much more pleasant experience for your users. Now, what if, once we get this data back, we have to do some additional processing to that information? Say we have some really extensive calculations that we have to run. Without any additional optimizations, we would have to run those extensive computations every time we render a page. Or we could use a specific type of caching called memoization. And so what memoization does is it gives us the ability to not have to run those extensive calculations on every render. So here's our app. Let's say this is a list of movies, thousands and thousands of movies. And in order to make sense of this information, we're going to have to map over this data. I'm using a JavaScript term, but we're just going to have to iterate over this data in all the metadata, the movie titles, the genre, the director, the actors, the plot, all of that good stuff. And this is going to take some time. This is a lengthy calculation because we have a lot of movie titles. Again, on every re-render, we're going to have to run this computation without any additional optimizations, even if the output is the same. What memoization allows us to do is say, instead of running this function every single time, if we have a pure function, and here's the key, is that we have to use a pure function, which is a function where if you always have the same inputs, you'll always get the same outputs. Rather than calling this function every single time we re-render the page, we're going to store the output in our cache, because literally every time we run this function, it's going to be the same. And the next time that we need, the first time that we need this function, we'll call the function with the inputs, we'll store the output. Then the next time, on subsequent calls, we will just grab that output from cache, and we don't have to run that expensive computation. So again, we're 5 years old, so I'm going to explain it to you like we're 5 years old. We have a color churn machine. And what this does is sorry, can you tell I have a kid? So we have a color churning machine. And if you put in colors, what it's going to do is it's going to mix the colors together and give us an output of another color. And we're going to use that color for our painting. But we need to make sure that we mix these colors very well. And this is going to be a lengthy process. This color churn machine, which between us represents a function, is going to take some inputs, and those inputs are always the same. It's going to be the color blue and the color yellow. So our output, color green, right? So it's always going to be the color green. Rather than running this color churn machine every single time, we are going to store our output in our store, our cache. And whenever we feel this artistic creativity bug, rather than running that function, we are just going to pull it out of cache, and we can paint. Okay? So that's that. The next step is, the next optimization bucket is rendering. And a lot of times we'll use the term rendering as an all-encompassing term when we talk about everything that happens from when the browser receives a request for a page to when we're fetching the data to when we're loading the JavaScript. What I mean here is just displaying the information for your users to see. There's two parts to rendering. There's the layout, and there's page painting. So the layout, and this is a React app, by the way, the layout aspect is where we're walking the component tree, getting all of the assets for your page, the HTML, the CSS, the images, the videos, and we're calculating the geometry of all of that and the placement of all of that, and we're putting it on the page. There's not actually anything that you'll see, but this is the best way to represent it visually in my head, is this is where we're saying, okay, your header's gonna go here, your nav is gonna go here, and yada, yada. The next step is the page painting, which is where we actually go pixel by pixel and fill in the visual representation of everything that we've parsed. So if we were 5 years old, I would explain it as, like, the way that I think of it is the way an artist paints with their canvas. But it's not a blank canvas, it's more like a paint by numbers. And so the layout part of it is where, again, you're not gonna see anything on the screen, but the layout part is where we're saying, okay, this is where the petals are, these are the ones that are gonna have gradients, this is what the styling rules are, and then when we're actually ready to paint, that's the page painting aspect of rendering. So what are some ways to optimize rendering? Virtualization is one. And when I'm talking about UI virtualization in this case, but when we talk about virtualization, we're typically referring to something that has to do with a list or a table or a grid, because visualization is a way for us to deal with situations where we have to display a lot of information on the page. So again, we have our huge list of data, movie titles, and all of the metadata that goes along with it. It's not pretty on its own, at least not to somebody who's looking for a movie to watch, right? So we're going to map over that information. We talked about the processing that we're gonna have to do, but then the output of our function is going to be, for every movie title, we're gonna dress it up. Like, we're gonna add HTML elements. We're gonna put divs and sections and asides. We're gonna put links and icons and event handlers and all that good stuff. And then our user gets to have this beautiful site to see all their movies, right, displayed. Great news, right? Yes, but there's also a caveat to it, is that this is slowing down the performance of our app, because think about it. For every one of those thousands and thousands of movies, we're putting so many HTML elements in the DOM. We're putting so much CSS in the DOM. We're adding event handlers, and our browser has to process that. So the more information, the more it is for your browser to process, and it's gonna slow your app down. What virtualization is rather than building for every single element that could possibly ever be on your page, we're only gonna build for the ones that are in your browser's viewable window, and maybe a little bit lower. So then as your user scrolls, and you've probably noticed this when you use like Facebook or Netflix, the elements get painted to the DOM as you scroll. And then as you scroll up and things get removed from your viewable window, they also get removed from the browser memory and from your DOM. So it saves your browser from having to do these expensive calculations all at once when it's not really gonna be necessary. Batching is another way to optimize. There are a number of different meanings for the word batching. What we're talking about here is event batching. Event batching is one of those things that you do every day, and I'm gonna show you this, and you're gonna be like, what? And so, but what I mean by batching is, it's a process of grouping together updates to state or events together to prevent unnecessary re-renders. So let's talk about this in terms of an update to state. Here's our React component movie ratings. Every time that we update state, we have two pieces of state here, account and a rating. Every time we do an update to state, meaning any time that we use one of these state updater functions, we're going to trigger a re-render. As we talked about, rendering, there's a whole bunch that goes behind it. There's the processing of all the data, the functions, the HTML, and painting the DOM and all of that. But aside from that, if you're rendering without the information being ready, it can cause weird side effects and bugs. So we don't always want, we don't want it to update state. We don't want a re-render every time that we update state. So here's what we're gonna do. This is batching, and I'm telling you, you guys do this every day. If you're using React, you already know this. We're batching. We're putting two state updaters inside of a handle click function, and then we're adding this to a button. So when we click the button, it's handling two state updates, which would by default be two re-renders, but rather than rendering twice, it's just rendering the one time for batching. Okay, so here's our 5-year-old explanation. If you want to explain it to your friends and family. Let's say you're at a restaurant, right, with your kid. And you're sitting there and the waiter comes up to you and is like, hey, what do you want to eat? And you're like, the chicken and waffles. And then so they run back to the kitchen, they're like, one chicken and waffles. And then they come back and then they're like, what does your kid want to eat? You're like, the chicken fingers. And then they're like, okay, go back, chicken fingers. Hey, what do you guys want to drink? And they just keep going back. That's without batching. If you're using batching, that's where waiters are like normal people and, and do it all at once. All right, the loading code aspect, this is where our browser loads and parses our code. Most apps these days have heavy amounts of JavaScript, and that will be a combination of whatever framework you're using. Like if you're using Create React app, right? It already comes with a bunch of JavaScript. Part of it is the code that you've written in your repo, and then another part of it is the code that you're importing from helper libraries, styling libraries. So there's a lot of stuff there, and the more code that's there, the more your browser has to parse, which you can imagine makes your app less performant. So there's an optimization that we have here called tree shaking. And I've heard this term used a lot. I didn't know what it meant, but what it is the removal of dead code. And this happens even before your browser gets your JavaScript. And so let's talk about this in terms of a tree. And if you're using it like a modern JavaScript app, like anything, if you're using Create React app, over the past 10 years at least, you have Webpack or Rollup, and those will automatically do the tree shaking for you. So it's not anything that you have to think about, but I want you to get familiar with the concept so that you know if anybody uses it, this is what it is. So literally, like if you think of a tree and you shake a tree, right, leaves are gonna fall out. The leaves on the ground represent the dead code. This is unreachable code that you're not using in your application. And the leaves that stay on the tree represent the code that's essential to your application, to running your application. So let's look at the code, and then we'll go back into the tree shaking stuff. So here is our app. App.js is our uppermost parent, and we're importing increment and multiply by 2, and we're invoking both of those functions. And then we also have this, the child, which is math.js. There are 4 different variables here, 4 different functions, but we're only using 2, which means that 2 are dead code we're not using. What these, like Webpack or Rollup or any of the bundlers will do is they'll look at the import statements and export statements to understand which variables you're using, which part of your code you're actually using. And so now we get to shake a tree. So the blue squares represent the code that we're actually using, and the dead code is the gray code. So we'll physically shake the tree, and then the dead code falls out. This is my favorite slide. That's great, right? So your browser has less stuff that it needs to parse and moves a lot faster. The last part is interactivity, and this is what happens after all of the other steps have been done. Interactivity is the relationship between your users and your application. That could mean a number of things. It could mean what happens when you push a button, click a link. What happens when you make a comment and being able to instantly see your comment in the UI, and the hooks that listen for the likes and the comments on the comments and all of that. When you're using a client-rendered app, it becomes interactive as soon as the JavaScript loads and the screen is viewable to your users. If you're using a server-rendered app, it becomes interactive once the app is hydrated. We'll talk about what hydration means, because I know it's burning in all your heads, right? But the first thing that we'll talk about is the difference between client rendering and server-side rendering. So if you're using a JavaScript framework like Vue, React, Angular, your app by default is client-side rendered. All of the instructions to run your code are held inside of a JavaScript script tag. When the browser receives a request for a page, the page sends the HTML, the JavaScript, the CSS over to the browser to be run. The browser paints the DOM, and then from there, your site becomes interactive. Videos play, modals open, the whole 9. Now, that's great, except that if your user has slow internet connection, or your app has large JavaScript bundle size, like most apps these days do, it'll take some time before that app becomes visible by your users, never mind even interactive. So until that JavaScript is loaded, all your users are going to see is a blank page, like this. Now, server rendering helps here It doesn't solve the problem of slow internet connections or large JavaScript bundle sizes, but what it does do is it gives your users something to look at before the JavaScript loads. So a typical app using server rendering works in this way. When the browser receives a request for a page, on the server, we will fetch the data for the entire app. And then also on the server, we will walk your React component tree and render your components as HTML elements and display those in the browser. So already, server rendering is providing an optimization on top of client rendering because your users aren't waiting for the JavaScript to load before they can see something on the screen. But remember, server rendering alone is not enough to make a complete app because yes, your users can see things, but they can't interact with it. Not without the JavaScript, aside from like basic HTML buttons and links and things. So we still need the JavaScript to make the videos play and the modals open. So the next step is that on the client, we will load the JavaScript for the entire application, and then we'll hydrate it. And at that point, it becomes interactive. So let's define hydration. So remember how in the DOM now, because of server rendering, we have this non-interactive HTML view of your app. Rather than painting the DOM with new DOM nodes, we'll walk the component tree and just attach event handlers to the elements that are already in the browser. Once that process is complete for your application, your app's hydrated, and it becomes interactive. At that point, users can use it, videos play, modals open, the whole nine. Okay? One thing that I wanted to point out is that, did you notice that all of the steps in both client rendering and server rendering all mirror the different buckets of optimization that we talked about? So yes, like by shortening, by streamlining, by customizing any of these steps, you can optimize. But you can also optimize just by changing the order to make your app feel more, more interactive, much more quickly for your users. And server rendering is considered an optimization on top of the client rendered process. So there's different ways to optimize. So we say server rendering is an optimization, but how do we measure what a more performant app is? Well, there are a number of ways, but Google's performance metrics are one of the most popular ways. So metrics like largest contentful paint, first input delay, are all ways that help us to understand how quickly, when a user comes to your app, are they able to do what they expected to do, see what they expected to see. All right, so we'll talk about each one and the definitions. The first one is cumulative layout shift. And cumulative layout shift, like all other metrics in the core web vitals, is a metric that helps us to understand how pleasant your experience is for your users. So what it is specifically is it measures the amount of unexpected shift in your app. So have you ever had this happen to you where you go to a site and you go to click something, and then all of a sudden some dynamic element just pops in and you accidentally click the wrong thing? So as you can imagine, this is a bad user experience. And in some cases, it can lead to some really sad results. This poor person got all their photos and videos deleted. So we try to minimize cumulative layout shift in our applications. Now, what we're measuring is unexpected shift, and we'll talk more about what that means. But we are measuring shift. Not all shift is bad. So think about like animation, for example. Like light animation can actually improve the user's experience. So our rule of thumb is that if a user takes an action and it causes some shift to the page, make the response happen as quickly as possible after that action took place so that your user can understand the relationship between the action that they took and the response from your app. Another aspect of it, and this is how we measure cumulative layout shift, a score of 0.1 or 0.1 or less is considered good. Another aspect of it okay, actually, I'll go back to that. So how we measure cumulative layout shift is it's a score of 0.1 or less. And it's calculated by multiplying a metric called the impact fraction by another metric called the distance fraction. So how do we calculate that? Here's our app, and we have this text that takes up 50% of the screen. Now, when this dynamic element comes in, it's going to shift the screen down by 25%. So a total of 75% of our app is going to be impacted by that shift. So this is called the impact fraction. Now, the distance that this shift was made was 25%. So this is our distance fraction. So to calculate what the CLS is just multiply that impact fraction by the distance fraction, and we get a score of 0.18, which according to Google is something that needs improvement. All right, so as I mentioned, animation, just make sure, and not necessarily for this metric, but just for the overall user experience, make sure that any action that your user takes happens right after any response that your app has happens right after your user takes that action. Also, if, and we're going to use this one as an example, also if your user's action triggers a network request that's going to take some time to come back, make sure that you put in a loader, and we'll talk about why. So this is a filter. When we open the toggle, we're going to show all results. So there's going to be some shift. One, we want it to happen immediately, but also we're going to put in some fallback spinners, and we're going to put them in the same size as the permanent information that will be coming in. And the reason is twofold. One, we want to give our users something to expect. We don't want them to just be clicking around all willy-nilly, accidentally clicking things and deleting all of their stuff. And then two, we want to eliminate the shift. So when the permanent elements come in, there's no shift to the page. Next metric is first input delay. And first input delay is a measure of interactivity in your app. So this is, and a score of 100 milliseconds or less is best. So this is measuring how quickly, as we talked about with cumulative layout shift, how quickly is your app responding when your user takes some action. As a developer, you're probably saying like, well, if I put in an on-click and a button, shouldn't it just handle that on-click right away? Not necessarily. There are a couple of different cases, like maybe your JavaScript is telling your browser to do something else. Maybe your app is still loading in multiple places, and without any optimizations, it can't handle a click. So your user is stuck with information, trying to click on this nav to navigate away. They're stuck with information that they're no longer interested in. And the JavaScript is telling your browser to just keep on, let's just keep on loading, like let's power through, we're committed, and then we can, we can handle this click. So the time that it took from the user's click until the action is able, the event handler is actually able to be handled by your browser, that's what's called the first input delay. The last one is largest contentful paint. And this one is a measure of loading speed. A score of 2.5 seconds or less is considered to be a good score. So we start the clock as soon as your page starts loading, and we measure the time that it takes for the largest piece of content to be displayed on the page. Now, Google used to measure the first contentful paint, and this is what the first contentful paint is. It's the first element that appears on your page. So it might be like a text box or an image, right? This is the first one. The largest one is what we're measuring, is the aside. So this is considered the largest contentful paint. So again, we started the clock once that nav started loading, and then we stopped the clock at the aside. So we want it to be 2.5 seconds or less. All right, now's the moment to be proud of yourselves, guys. If we're 5 years old, I'm gonna tell you to give yourself a pat on the back, give yourself a round of applause. These are all the terms that you learned today. So thank you for enjoying this time with me and letting me be myself. Class dismissed.